Live from our Lakeview studios in the Windy City, welcome to Chicago Python's WebDev/DevOps Special Interest Group meeting. My name is Sivji. I'm going to be your host for this evening. I'm one of the organizers of Chicago Python. Thanks for taking some time out of your Tuesday evening for coming to join us and learning about some Python. Let me share my screen for our slides. So we do have a code of conduct. If more information is available on the website, anywhere you are in a ChiPy space, this could be our live chat, it could be our Slack. Just please be careful of your of how you're portraying yourself, especially in sort of these times. So we are all wondering, what is ChiPy? Well, ChiPy, or the Chicago Python Users Group, is a Python-focused group that has started back in 2003. It all really started with a few Pythonistas. They're meeting once a month at the back of a bar or in a conference room. And we've grown from those humble beginnings to become one of the largest Python communities in the world. We have around 6,000 members, and every month we hold 4 to 6 events. On top of our headline events, which are our main meeting and project night, we have special interest groups that focus in on more of a niche area of Python. So we have the data SIG. We have this one, which is the WebDev/DevOps SIG. We have the algorithm SIG. That's actually going to be happening on Thursday night. And then we have the finance SIG. So do want to just make some announcements. Python 3.9 beta RC candidate, beta 1 came out. So just check that out. Try it against what your applications are sort of doing in terms of like production, but don't run it in production. Just like make sure you can sort of get the environment up and going. If you do experience any problems, please do make bug reports. That's what the developer sort of looking for there. A book just came out, C Python Internals by Anthony Shaw. It's on sale till Thursday night. So if you go to realpython.com, I think you can pick it up for $20, and it's usually around, I think it's around like $50. So yeah, check that out if you're interested in getting to know a little bit more internally how Python works. I do want to make everybody aware of our upcoming virtual events. On June 4th, which is this Thursday, we have our algorithm SIG. On June 11th, we're going to have our main meeting. We have 3 fantastic talks. And then on June 17th, we're going to have our data special interest group, and that's going to be a themed event. We have 2 talks on natural language processing. ChiPy's also sponsoring the Python Web Conference. This is going to be a virtual conference held from June 17th to June 19th. If you would like more details about that, you can go to that website. As a sponsor, we have been given a few tickets. We're going to be holding a Python Web Conference ticket giveaway. So if you're interested in getting a ticket, fill out that form, which is bit.ly/chippy-June-2-giveaway. At the end of tonight's event, during the event, I'll write up a random number generator, and then we can just pick a winner, and I will email that person. So you don't have to stick around. So just fill out the form. I will email you if you win. Good luck. Or may the odds be ever in your favor, I think is probably the better way of saying it. So where can you find ChiPy? We have a very active Slack community. There's around 2,000 members. You can go to joinchippyslack.herokuapp.com, send yourself an invite. We're always going to be tweeting what's going on in Chicago as well as the wider Python ecosystem. Follow us on @ChicagoPython. All this information plus more is available on our website, chippy.org. So tonight we got 3 fantastic talks. First of all, we got Dražen Lučanin from Croatia. Thanks for joining us, Dražen. He's going to be talking about how to deploy Django efficiently. We also have me.
Hello,
my name's
everyone.
Sivji. I'm going to be talking about pluggable architecture. And then we have Derek Steinmoeller joining us from Waterloo, Ontario, Canada. And he's going to be talking about Boost.Python C++ bindings. So looking
Hi,
forward to
everybody.
all of that. Thanks for joining us, gents.
My pleasure.
We're glad to be here.
Awesome. I'm just going to put you guys down below, and then we'll just keep going with the rest of the intro. Let's see. I do want to make everybody aware we have our live chat. It's going to be to the right. I hope I'm pointing to the right. It's going to be to the right of this window. If you do have questions for our speakers, put them in this chat. There's going to be around like a 15 to 20 second delay. So if you'd like to ask your questions a little bit ahead of time, we can just sort of save ourselves the dead air from waiting for those questions to come in. Let's see. Yeah, that's it for the announcements. Let me hide that. So I'm going to bring back Dražen to our live stream. Hi, Dražen. Welcome to Chicago Python.
Hi, Ali. Glad to be here.
Awesome. So yeah, let me just pull up my questions. So can you please tell us about how you got into Python?
Sure, Ali. Yeah, so I basically
Actually, I'm sorry, I missed the question. Can you introduce yourself to our community, first of all? I'm sorry about that.
Sure, no problem. Yes, so hi, everyone. I'm Dražen. I come from Zagreb. I'm located here right now, but I'm very glad to participate online in the Chicago meetup. I got a chance to visit Chicago before last year's PyCon. And basically, I do web development as a freelancer, web development, data science with a small team of freelancers. We're called Dev, and yeah, that's a very short introduction.
Cool. So as a freelancer, what are some of your favorite parts of freelancing?
Well, I'm very, very enthusiastic about working with different companies on different fresh projects. It's a very dynamic role as opposed to being an employee in a single place for a long time. Doing freelance development, it gives me a chance to meet new people, different distinct groups, and get to know their protocols, learn something from how they work. And it's always a new challenge coming into a new team and getting adapted. So I really appreciate these things.
Yeah, that's awesome. Like that's, I think, the best way to learn is sort of just work on as many projects with as many people. You'll be exposed to so many different things. But yeah, let's talk about your Python journey. How did you first get into Python?
Yeah, so I studied computer science, like the classical, maybe a bit of a boring backstory. But when we were starting our studies, like the languages that were typically pushed onto us were C, C++, Java, and so on. So very early on, I just through Googling online articles, I bumped into Python, and when I realized I could do my lab assignments for some courses in like 1/3 of the time in 1/5 of the lines of code, that really was a discovery for me. And from there on, I just kept digging deeper. Went to my first EuroPython, and there really fell in love with the community. So from that moment on, I basically wasn't looking back anymore. So
yeah, I feel
dynamic
like
languages for me.
Yeah, I think the community is brought a lot of us together. But yeah, I really enjoy the fact that you can make Python pretty much do anything. Do you have a favorite feature of Python?
Let me think. So, F strings come to mind. They're a very small thing, but it makes you happy to be able to write things more concisely. I also really like the new async await syntax. I really like the general direction of making Python more cutting edge and getting the latest and greatest from programming languages.
Yeah, it's the async and await just makes things so much cleaner. But to get just a little bit more serious, things are been a little bit difficult with sheltering in place. A lot of our community members have been experiencing isolation, loneliness, And just sort of want to get your, like, how have you been dealing with sheltering in place?
Yeah, well, basically, I guess like a lot of the listeners here, like one of the first things we got to get used to was like the lack of physical meetings, which wasn't too big of a change since I was working remotely often, but still just being not able to use my co-working space anymore, meet my colleagues, and having to make my home office my new focus of both life and work. It was challenging in this transitional period. Like very quickly, I had to learn a bit about ergonomics and making the home environment a bit more comfortable, and just getting into some habits to keep sane. Just been practicing some yoga and jogging and so on. I guess we're all adapting in similar manners to not go insane from being stuck in the same space for too long.
Yeah, it's you got to move it around a little bit, like try to get outside if you can safely. I try to walk around at least my apartment as much as I can, like once an hour while I'm drinking a glass of water. Just sort of my habit. Cool.
Yeah.
So are you ready to get started with your presentation?
Yeah, sure. I'm ready if you are.
Yeah, let's if you don't mind sharing your slides.
Mm-hmm. Okay, share screen.
And also to everybody out there, I did see that we had 799 subscribers as ChiPy. So if anybody wants to make that 800, we'd appreciate that. All right, Dražen, perfectly. We see your screen. Please take it away.
Awesome. Yeah, just one note. I don't see the chat. So if there are any questions, could you please interrupt me and mention it maybe?
Do you want to wait till the end or do you want to go as they come in?
Well, if questions come in the middle of slides, I can also take them during the slides. Okay, great.
Cool.
So hi everyone once again. The topic of my talk is efficiently deploying Django. Can everyone hear me okay?
Yeah, we can perfectly.
Okay, awesome. So yeah, let's skip the introductions because we already did that. So let's get right into the topic. So you went through the Django tutorials, you maybe went through the post tutorial and you created your awesome new Django web app. Maybe it's something like a database for family culinary recipes or something similar, something you want to share now with some more people. And then you come into this first challenge of basically how do you share with other people if it's just running locally on your machine? So how do you let others use it? So you just need to deploy it. Sounds simple. Well, if you start researching what are the options out there for simply deploying a Django app, you'll very quickly jump into this documentation page on the Django docs, which starts into some very interesting subtopics like what is Apache and what's uwsgi and how do you connect these two? Basically, this brings us into the first chapter of deploying Django, which is self-hosting. So, to take a step back, some of the things we're gonna talk in this first segment of the presentation is connecting the core components. So to deploy Django web app, you need a web server that's gonna be hosting your app. You need a domain that's gonna be pointing users to this web server. If you're doing anything more complex using Django models, you're gonna have to store them in some sort of database or multiple databases. And then you have some core actions, like you want to start everything up and keep it running. So to allow people to connect to the server. And lots of the things, maybe not the least though, is the security aspect. So you want to keep track of your error logs, warnings, and make sure everything is basically transferred in an encrypted manner to the client, that you have backups and so on. Okay, good. So are you ready to jump into the rabbit hole? Let's now dive into each of these components and see how you would set them up if you were to self-host a Django web app. So the web server first. So no, we're not going to use Apache like the official docs still predicts in the first place. So, these days we'd go for something like nginx. That's another web server you can use. It's much more popular and, better supported. Now, a problem with nginx, Apache for that matter as well, is that it doesn't support Django directly. So you basically need to tell it how to run Django. So it doesn't know how to run your manage py run server script. And you would run Python manage py run server directly either, because it's not performance. It's meant for debugging purposes, and not safe to run into production. So what you would need to do is set up a production-ready application server like uwsgi or gunicorn that knows how to run your Django app. And then you would route this part of the traffic from the nginx web server to something like uwsgi or gunicorn. But then we come to static files and media files, which they don't go to this Python server. They are served by the web server itself, because that's more efficient. Okay, so you figure out how to set this up, then you are connecting to the domain. Now you need to register a domain. You need a domain register. Namecheap is a good option. So if you have a fixed IP of your server, you would set up an A record, or if you're forwarding to another domain, you would set up a CNAME record. Just don't forget, if you also use the domain for MX rules for emails, basically you have to make sure they play nicely. So check if your register has a name or alias support. You can also, which is a very common approach, just connect your app via a subdomain like app.mydomain.com. Good. Okay, so we've connected the domain to the web server. Next comes the database. So you want a Postgres for the relational part, for storing your persistent Django models. You might need additional databases. For example, if you have a task queue in Celery, you need a backend for that. You could use Redis, which is a decent option. And now you need to go through each of these services, follow their tutorials, and get them set up. So now let's say you've set everything up. So how do you start it? Some things like nginx and Postgres, your operating system is going to start up automatically as soon as it's up. So let's say you use an Ubuntu VM, it will just start up these services. But what about your Python server? So say you use uwsgi. For these things, you need to set up your own service to start them up. And for this, you could use either systemd, which comes with Debian-based operating systems, or you could install a separate service like supervisor. Yeah, it's another one of these very long and detailed tutorial websites that you need to go through, learn the ins and outs of to get it configured. After you have the services up and running, you still need to set up logging and monitoring, because of course things are going to get broken. You're going to get errors occasionally, and you're going to want to know about them. So get some notifications about these errors. And lastly, I mentioned security. Oh yeah, we need to encrypt the traffic. Otherwise, the new Chrome browser is going to pop up these ugly, not secure warnings for your users. So you need to use Let's Encrypt, another tutorial. But then again, Let's Encrypt expired. So you need to set up a cron rule that's going to auto update your certificate. You're going to have to upgrade your nginx config, and so on. Are you tired yet? Well, there are still upgrades to worry about. So hope you're upgrading your operating system, because it doesn't do it on its own. So say you used an Ubuntu virtual machine to host the web server. Well, it gets notifications about security upgrades, but it doesn't run on its own. So you need to enable unattended upgrades if you want to have these most important security updates. You still need to occasionally, log in and check up on things to just make sure you didn't miss another, important update that doesn't come in automatically. I've created this handy little Ansible script that enables unattended upgrades for your server. That's not on by default for some reason. And don't even get me started on backups. So you have all of these services now that now you want to back up in case the computer crashes, because as you know, there are only two types of hard drives that are dying. So when they do die, you want to have a backup you can bring up on another machine. Okay, we have systemd, microwsgi, Sentry, nginx, Namecheap, let's encrypt. It's really a whirlwind out there of all these technologies you need to put together to get your web server running. And you can see, what are some of the downsides of this self-hosted approach. So I was a bit fast in this segment, so I hope you're still bearing with me. So in summary, I wanted to say that we really need to set up a bunch of these services, and we are the ones responsible for maintaining them once we do that. These services will break and change over time, which is a problem. And we still didn't cover how do we tell Django where everything is, how to configure everything. Can this be automated? Yes, to an extent. So, there are many things you can do with things like Ansible or other configuration management tools, Salt, Chef, Puppet. But there are better ways, which leads us to chapter 2, the 12-factor app, which is the part I actually want to focus on much more than the self-hosted approach. So the approach we're taking here is you have a problem. Well, great, start throwing money at it. This is where the platform as a service model comes in. There are lots of services out there function in this way. One of the popular hosting services is Heroku, and at around $7 a month, you can get a Heroku dyno. And what is dyno? Well, it's something that knows how to run your Django app. How does it work under the hood? Who knows? It's someone else's problem. That's what we're paying them for. It's a very simple approach. It's a bit sounds crude maybe, but we'll get to appreciate this hopefully, especially after the whole self-hosted segment. So remember all those services that we had to painstakingly set up on our own and maintain later on. Well, in Heroku they just come built in. So if you need something like Postgres or Redis, you can install it as a plugin, and it's just connected to your app. There's even a whole marketplace of these services you can use. If you notice later on, when you need Elasticsearch, maybe for a full text search, as I needed to add in one of my recent projects, you can just dig through this app store and find the service you need and enable it. Is there a catch? There always is one. So besides from paying more money for it, there is some amount of configuration necessary to make this plugin model work. Now, the way Heroku handles this is they came up with the 12-factor app methodology, which I'm going to explain. It requires us to rewire our app in a way, but don't worry, it's actually a good thing to think in such a way, as you'll see. So let's quickly glance at these 12 factors. I'm not going to focus at all of them because some of them are going to take us on weird segues. The important ones are that you have a single code base, which is trapped in a revision control, and it allows you to do many deploys from it. So you have one Git repo that is responsible for maybe your staging, production, dev server, and so on. And number 3, the configuration is stored in the environment, or more precisely, in environment variables. That's something to really think about and internalize. So we don't have any config files or text files. The code is always the same, and in the server's environment variables, we set everything that's necessary to actually describe our deployment. There are other things involved in here, and they're all kind of good practices, and it's good to read more about this. But we want to get to the more practical aspects, so let's move on. So how do we start? Well, you can of course follow the official Heroku tutorial on getting started with hosting a Django app there. What I'm going to explain in this talk is how you can do it using this Django REST YAML generator that I've created. and is open source. It's written in JavaScript, but don't tell anyone. There are reasons why I did it in such a way. And it's fairly easy to get started. So assuming you have a couple of basic dependencies installed, like Python, Node, you can install Yeoman, which is the framework I'm using for my generator. You can then install the specific generator called generator Django REST, and then you can get started. So now I'm going to switch from my slides to the terminal because I have a demo to show. Can you see my terminal? Okay.
Sorry, I was muted. Yeah, it looks good.
Okay, great. So I'm making a new folder for starters. I'm going to call my app Aviato. And inside it, I do yo Django REST. And that's everything you need once you've installed the npm packages to get the app started. So you follow this interactive prompt to answer a few questions, like I'm going to keep the name of the app as Aviato. There is some more front-end support that I'm not going to get into now. You can give it a GitHub URL if you want to sync with GitHub right away. And there it is. It's created this project layout for us. And we're going to examine later on in an editor what we have in there. I'm going to have to magnify the screen a couple of times so you see everything. Basically, there is a scripts folder in there where you have a couple of useful scripts. One is install, which I'm going to call first now before I start explaining anything inside the project. And what the install script does is it installs all of the dependencies locally on your machine, and it's using pipenv as the package manager on top of pip itself. So the repository is a standard Django project you would get if you just did a Django start project. It comes with some documentation inside this hacking MD folder showing you how to get started and how to later on deploy the app. Most of the magic is contained inside this scripts folder. So there is an install script that basically initializes the Git repo, installs the file, installs the dependencies, and creates an empty Postgres database. And we have a start script that will then run everything using Honcho. Honcho is Python's program for basically parsing these proc files, where you can specify in every line what service are you starting. Okay, let's see what's happening in terminal. It's running some Python dependencies. If we look at the app itself, it's fairly boring. So the only thing that's really different than the normal Django project is the settings file, settings.py. And what I added inside the generator is the Django environment project, which allows you to then, in a more streamlined way, extract values from environment variables. So as I said, in the 12-factor app paradigm, all of the information about your deployment comes from these environment variables. So you can do things like, extract the secret key from the secret key environment variable. If there is, let's see, if there is a Redis URL inside the environment, you would pull it out like this by querying the env object, and so on. So by now, okay, all the dependencies have been installed. So I can now go into the scripts folder and call the start script. And what this does now is it starts all of the processes from the proc file, so the Celery worker, the web process, and it should be running now on localhost 8000. And you can see now the template, it's running live. So it's a Django REST framework project. So you have the REST dashboard here, and you have the normal Django admin interface that you've hopefully learned about in the tutorial you were following before you even started on the task of deploying the Django web app. Great. Now, just starting an app locally probably isn't so impressive by itself. So this takes us to the next part of what we can do with our generator Django REST project, which is deploying the app. So if we open the hacking MD file, here we have some instructions of how to create a Heroku app where we can deploy this Git repo. So I'm going to create it right now. I'm call it my Aviato because Aviato is taken. This first command basically creates the app on Heroku. The second one just creates a local Git remote, so that when I do a git push Heroku master, my repo knows where it's pushing to. And then I'm creating some plugins on Heroku. This is the part I mentioned where Heroku treats everything as a plugin, all of these external services. So if I open my dashboard, I should see the new app I've just created here in my personal Heroku apps. And here is Aviato. I can see it's created. I've attached a Heroku Postgres plugin. In a similar manner, I can create a new add-on for the Redis database for the Celery backend. And all of these things, they're visible in the dashboard of your app. So if we just give it a second, it should instantiate the Redis add-on as well. We can see it's working here. And once all of this is configured, I'll be able to do scripts deploy, which then does the magic sauce of, I can show you basically what it does. Git push Heroku master. So some of these scripts are really very simple. We'll just wait for this to provision. It's done, great. So I can do scripts deploy sh. And it's gonna take a while, but basically that's everything you need to do. In just a few minutes, you deployed your whole app without doing all of these steps that I mentioned in the first part of installing all the servers to get your app running on Heroku. I'm gonna continue with my slides now. We'll verify that this is working later. So once everything is live, you should see the same interface I showed locally just on the internet on myaviato.herokuapp.com. So how does it work? I've shown you basically the settings part. That's the most important thing. So basically by saying specifying inside the project where your Redis and Postgres and so on databases are coming from, Heroku knows how to connect these add-ons, the Heroku add-on, the Postgres add-on and the Redis add-on to your Django app, and they just work. So because they use all of these standard port numbers, URLs, and so on, your Django app will just know how to connect to these services. And the best part is all of these services are managed by Heroku's DevOps engineers, so they keep everything running. Let me just pop right into the terminal to double check if this is done. Okay, it's released. I can now open this URL, and the app should be live on the internet. Awesome. So you can share this with your family. They can use your culinary recipe app, and everything should be there as you'd expect it to. Perfect. That brings us to the end of chapter 2. And now we're in part 3 or chapter 3, which is the self-hosted 12-factor app. Okay, so why do we get into this? So Heroku, for all its benefits, can get a little expensive. So these $7 a month dynos can easily become $14 a month dynos if you need periodic tasks. So maybe you need a scheduler that has to be a separate process. So you need to cash out for another dyno. Also, this might just be, like we mentioned, a hobby project, maybe a culinary app for your family. Maybe it's a startup project that's not generating any revenue yet. Maybe you don't really have many users just yet. So if you're not making any money from these apps, these costs can really add up quickly. Luckily, the open source world, as with a lot of things, has our back. So in comes Doku. Doku is an open source alternative to Heroku. So it's a self-hosted Heroku. Now, it maybe sounds a bit counterintuitive. So like we talked about all the downsides of self-hosting in the first part. Now we want to self-host something. Well, it's kind of a nice compromise. So it's a bit cheaper. So if you get a $5 DigitalOcean droplet, or in the EU, there's KOA, which I use. You can get this kind of your own Heroku running, where you can run lots more apps. So it doesn't have to be just a single application. It can be tens of apps easily running on a single server of yours, especially if these are all hobby projects where you don't have that much traffic. But it respects the Heroku 12-factor app methodology. So as long as your app is running on Heroku, you can deploy it to Doku as well. And this is the approach of treating your service as cattle, not as cats. Not as pets. So if something is not working, just commission a new VM, set up a new Doku instance. It's just a couple of commands to get it running, and you can just deploy there from scratch. You don't have to fix things that aren't working and worry too much about the configurations and so on. So how do you do it? So if you follow the template that I've shared in the hacking MD file, you can find the instructions. This is basically the whole procedure. You again install a couple of plugins, create the app on your Doku instance, and link up the databases. A few commands to get Let's Encrypt working, to have HTTPS, and that's it. So I'm not going to follow these steps to save time, but basically by following the same procedure, you can get your app running on your own server. Okay, this is basically it's what I wanted to mention from ways of deploying Django. I have a little aside though to talk about what about production. So these techniques I've talked about, they mostly are good for your own projects and when you're first starting out, even if it's a startup project. But when you get to the level where you have lots of users, very serious use, you're talking about uptime, scalability to new numbers of users, it's a whole different topic. And I really would encourage checking out some old PyCons. There are lots of good talks to learn about these things. Some pointers that I'd mention is that there are ways to deploy the app using Amazon's container service. You can use their database services. Kubernetes is a big thing. There are also ways to deploy your Django app using AWS Lambda in a serverless manner, which is a different architecture. But the reason why I didn't want to talk about these approaches is that they're, in my opinion, not the best approaches when you're just first starting out. So in this stage, you probably want to see if users are going to like your app at all or not. maybe, it doesn't make that much sense to put all this effort into making a super scalable app when you still don't know how useful it's going to be to people. So, maybe don't dive into this rabbit hole, and it really is a rabbit hole. And when you do, either educate yourself to become a good DevOps engineer or hire a good DevOps engineer, because this really is a topic all onto itself. So to conclude, don't reinvent the wheel. The 12-factor app methodology rocks, and Heroku and Doku rock. They're really useful and good projects to check out. And most importantly, get out and have fun working on your side project. Thank you.
Awesome. Thanks so much, Dražen. This was great. Can we get Dražen a round of applause in the chat? If you do have questions in the chat, please ask them down below or ask them to the right over there. I do actually have a question. So one of the things that I had a side project going, it was the Slack bot for Chicago Python. And the thing that I always found is how am I supposed to back up my database? Do you have any recommendations on that?
Yeah, I do. So basically with Heroku, it's fairly easy. You can set up snapshots in there. There is even a separate Heroku Postgres backup add-on that really focuses just on backups. So you can set up a schedule to do nightly backups, weekly backups, and so on. And it's very easy, from just the web interface without getting too technical to bring back data from previous timestamp.
Yeah. So that's just gonna be an add-on, a couple dollars more or something like that a month?
Exactly. Yeah. I think it even starts free. But yeah, as with all of these Heroku things, as soon as you exceed the free tiers, like the Postgres add-on, I think it has something like 10,000 database rows, which we exceed this fairly quickly. That's why I also wanted to give an option of how to do something without Heroku if you are a bit constrained on your budget.
Yeah, and definitely if your app becomes serious, your database is the number one thing you should start thinking about. You probably should just start paying somebody to do that for you versus worrying about it yourself. So we do have a question in the chat. They're wondering, can the Yeoman generator be used for creating an app that can expect heavy traffic?
So like I said, there's the getting your app deployed part, and there's the real production. And I think these are two separate topics. Sure, you can build on the app generated with my Yeoman generator. You can start with that and start building this very scalable architecture from it. It definitely doesn't include all of the things you would have to get into, all of the load balancing and configuring some sort of auto layover to different instances if one is not available. So that's definitely something that's a separate topic, and we get into parts that are more app specific in these cases, I think. Because different app architectures have different needs, and especially it really depends how you want to run your app to make it more scalable. So one way would be just to start with, if you are deploying it on Heroku. Heroku allows you to just add more processes, more instances, so it's not that difficult to add scalability in such a way. If you opt for something like Docker containers on Doku, there it gets a bit more tricky, and I'm not really an expert on each particular of these workflows, so I intentionally didn't want to make this a part of the project. If there are some people who have ideas of how to already build this, and I'm open to suggestions. I just I wouldn't start from the get-go when you're just starting a project with this super scalability in mind. You don't have to be Google from day one.
Yeah, it's they always say it's what is it? Make it, then you make it work, and then finally you make it fast. Like, don't solve problems that you don't have. Like, your data model can probably do most of the heavy lifting if you like step back and think about it. So just going down that sort of same avenue, like, when do you start thinking about scaling out from, say, like just like your web app to a web app with a worker process?
Well, that for me comes pretty naturally. So as soon as I have some tasks that would be choking up the responses to web requests too much. For example, email sending is a perfect example. So you need to talk to a third-party API. An email is anyway something that doesn't arrive instantaneously, so it's usually a natural candidate to be separated into a worker process, and there you usually bring in Celery. Again, it depends on your app specifics. So some domains have different needs. Some domains might not even need an async task queue like Celery. But I find in most examples, you fairly soon need something like email sending, and there you plug in the Celery worker just to be able to do that.
Yeah, for sure. It's always I think email. It's like I'm always using like requests to do something, so it's like I don't want my request to hang for a minute while I'm using another library to go out and make more requests.
Exactly. Yeah.
So before we do let you go, do you have any action items or words of wisdom for our community?
Yeah, well, I say once again, I really encourage all of you to, start working on your side projects. I that's one of the things I really appreciate about the Python community and that I like to see more of. One maybe call to action would be, just go check out generator Django REST. I'm gonna post the slides on this link. You can't see it anymore. Okay, yeah. So I'm gonna post the slides on these on this link, and basically, I'd really like you to try out the project and let me know what you think. Even if you have some issues, for example, the Windows support right now is kind of non-existent. I focus mainly on Mac OS and Linux, so I'd really like to see more people try the project out. Let me know how it works for them, and maybe together we can make it more general purpose to make easing into Django easier for newcomers and just more experienced developers who just have never deployed Django before. So That's it from me. Thank you.
Actually, we got one more question, but could you also mind sharing? We just had a question come in, but before we get to that, do you mind sharing a link to your slides in the YouTube comments as well, just so people have it there?
Yes, definitely. I'll do
awesome,
that.
Perfect. And we have one last question. And what is a good intermediate or advanced book about specifically Django programming?
So for a beginner resource, I usually recommend the Django Growth tutorial. I find it even sometimes better than the official tutorial. And as far as advanced resources, I would recommend the 2 Scoops of Django. I think that's a natural candidate. I think there's a new version coming out now, Django 3. Basically, it covers all of these more advanced recipes on how to deal with more real life examples and gives you some good opinionated tips and tricks. I'll post these links in the chat now as soon as I hand over the microphone.
Awesome. Yeah, and that book actually just released in early release, I think a couple of weeks ago. So they are updating it, I've heard, for async Django, which is going to be interesting to do.
Awesome.
Yeah. Well, thanks so much. Thanks so much, Dražen. It was great having you on. You've actually been our guest from the furthest away.
Thank you, Ali. I'm glad to claim this title.
Awesome.
Well, hope to talk to you soon then.
Yeah, thanks. We'll hope to see you at PyCon next year.
Yeah, definitely. I'll try to be there.
All right. Take care.
Okay. Bye.
All right, so that was Dražen Lučanin talking about how to deploy Django effectively. He's going to be posting links to his slides in the chat, so look out for that. I just want to make everybody aware we have a giveaway. So before we go to break, I just want to bring that link up. I should have set this up earlier. Okay, so go. So Chicago Python is one of the community sponsors of the Python Web Conference, which is happening on June 17th to June 19th. It's going to be a virtual conference. I think there's going to be 1 day of tutorials and 2 days of talks. ChiPy does have a couple of tickets to give away being community sponsor. So if you go to bit.ly/Chippy-June-2-giveaway, put your email and name there. And at the end, I will write up, I'll probably live code a random number generator, and then we can pick a winner. So that's it for us for now. We will be back in around, let's say I got 6:51, so we'll be back at 7 o'clock. Thanks so much, everybody. All right. Before we do start, there are some announcements I wanted to make. Welcome back to Chicago Python's WebDev / DevOps Special Interest Group event. I'm your host, Ali Sivji. So let's go from the top. So we just had our first speaker, Dražen Lučanin, talking about how to deploy Django effectively. Our next talk is going to be me, which is like a little bit awkward. I have a lot of screens, a lot of windows going on. I'm going to be talking about pluggable architecture. And then after that, Derek Steinmoeller is going to be talking about Boost.Python C++ bindings, which I'm really excited about. We really don't have a lot of these like advanced level talks, and excited to hear that. So ChiPy is a sponsor of the Python Web Conference. That's an event that's going to be happening on June 17th to June 19th, 1 day of tutorials and 2 days of talks. As a community sponsor, we do have a couple of free tickets that we're giving away. We're going to be giving away one ticket today, and the second ticket, I believe, on June 11th, which is going to be our main meeting. So to get a chance to win a ticket to this conference, go to this link, fill out your information, and then we'll pick somebody at the end of this meeting. You don't have to stick around until the end. I'll send you an email with how you can redeem the ticket. Good luck. All right, so let me unshare my screen, get the presentation window going, and then we can sort of talk about pluggable architecture. Cool, awesome. All right, so my name is Ali Sivji. You can find me on Twitter. I am at KaiaSivjis. I'm one of the organizers of Chicago Python. I usually talk a lot about Chicago Python since these are my standard slides. We are on YouTube, as you're all aware. If you have not done so and you're still here, click the subscribe button down below. Hit that bell icon, get notified of our upcoming events. Let's get started. All right, so from the top, a plugin is a software component that extends or enhances an existing program. When we have plugins, it doesn't really do anything by itself. We sort of need some software we can plug into. Web browsers, they're built with pluggable architecture, and all these web browsers have a huge ecosystem of third-party developers making software for things like ad block, password management. I have a Chrome plugin for Vim key bindings, and of course there are a ton of plugins for developer tooling. I use a lot for React and like Chrome Dev Tools as well. When we have an IDE or a text editor, chances are it's probably going to have a plugin system. So this is just a snapshot of my VS Code. I have plugins to make debugging a little bit easier. I have a plugin to improve my user experience, to interact with third-party things like Docker, like GitHub. I also use a plugin to add support for a query language. So here you can have support for GraphQL. If you've ever used a media player, chances are it probably has a plugin system. So media player plugins support new file types. You can change a user interface. They call those skins. Does anybody remember those fantastic visualization plugins from Winamp from really, really back in the day? WordPress, that's a very popular content management system. It was written in PHP. It's estimated it powers 35% of the web. And yeah, WordPress is powered by plugins. There are thousands upon thousands of WordPress plugins that customize WordPress to do pretty much any kind of thing. WooCommerce is a WordPress plugin that enables e-commerce on your website. WooCommerce actually has its own plugin system, which means you can write custom plugins for a plugin. Your favorite web framework, something like Django, Flask, I didn't get a chance to put the logos, but like Falcon, Pyramid, all of these libraries have ways that third-party libraries can customize behavior and extend functionality. We can add something like a custom middleware, custom serializer. We can have custom ORM fields. PyTest is another popular library that uses plugins. That's one of the reasons people use it. You can add any kind of custom behavior during the test run. PyTest has a plugin system for you to hook into. And if you start digging into the PyTest codebase, you can see that PyTest, it's built on top of a plugin management tool called Pluggy. So Pluggy manages all the plugins of PyTest. It also has a hook calling system that's made specifically for PyTest. In fact, PyTest's core functionality is actually implemented as plugins. They spun out Pluggy into a separate library so you can use it for your own applications. Honestly, these are a lot. I'm sort of giving my first time giving this talk. Sort of have a lot of things on here. So another popular web scraping tool on Python is called Scrapy. And here you create custom scrapers, which the framework loads as runtime. And it scrapes data from a website. And that's sort of done like a plugin. Pandas also has plugins. So in Pandas, you can extend it with registering a custom accessor. So something like the DT or Geo. And they recently added extension types to add new types, sort of the way they did with like how they're wrapping NumPy types. So with all of these plugin systems, there are many different benefits. That's why people use them. So with plugin systems, third-party developers can extend your application. They don't really need to know the core functionality to do it. They don't need to know how everything works. And also, if you take a page out of PyTest's playbook, you can implement your core functionality as a plugin. But there are some trade-offs to using plugins. Like any type we use an object-oriented solution, it means that we have to spend a little bit more time doing design up front. We got to know what our objects are and how they interact. With plugins, it's really hard to, well, it's not that hard, but it's harder to write the core application. We have to add complexity in our core application to handle these third-party plugins that dynamically get entered and loaded into our system. This kind of complexity, it's really not that big of a deal because we do make things a little bit better for our third-party developers. So this talk is really about designing a plugin system. So we talked about a few different types of plugin architectures, but they all really share a lot of the same common characteristics. So plugins, they're loaded dynamically at runtime. This means that when the program first starts, it has no ideas what plugins are going to be used until it actually loads them in. Plugins and the host, they need a way to talk to each other. Plugins need to be called with code. I've written plugins that communicate over something like WebSockets. There needs to be some sort of two-way communication channel. And once we have a communication channel, plugins will need to register themselves with our host application. And this is done many different ways depending on the application. So some programs, they're registered plugins from a folder. So if you want to load a new plugin, just create an entry in that folder. And if this sounds familiar, this is sort of how Python works. When we pip install a library, all that code, it gets saved into our site packages. And there we can import them into our program. Other programs with plugin architecture, they might require you to be a little bit more explicit. In Django, we can use middleware plugins by explicitly listing them in our settings.py. And this is something I actually prefer. Like, I like the whole idea of explicit is better than implicit. And so once we have a communication channel, plugins are going to need to register with the host. And then they're also going to have to have the host call this plugin. So once you register for it, you can actually specify things like, what actions do you care about? And then the host program, it's only going to call your plugin when that certain event was triggered. So this is really part of a larger like 45-minute talk. Don't really have a lot of time to go into too many details, but I did actually come up with like a live demo over the past like week or so that I just sort of wanted to walk through. That's not that way. That is that way. Cool. Let me make sure everything is sharing. Yeah, that looks good. Awesome. So we have this project. It's going to be a command line tool to print out in version control platforms like GitHub, Bitbucket, or GitLab. So we'll just go through the CLI code. So I'm just going to be using argparse to get my things. And here I'm just going to be accepting a URL, parsing it, and calling my getFetcher class. Inside of my getFetcher, I have some code to load my plugin. So here you can see I have a Bitbucket plugin, a GitHub plugin, and a GitLab plugin. When I initialize this this class, when I pass in the URL, based on the plugin, it's just going to do a check to make sure that the plugin that we registered can actually be used by that specific plugin. And then if it can, we're going to call that we're just going to call something here. Just like sort of set our instance variable. And then at the end, we're just going to get some stats. So let's start digging into our base plugins. And so this is my base plugin. Some people use abstract base classes to make things a little bit cleaner. I just like doing things in a very simple way without like adding a lot of overhead. So here I'm just going to specify that my base plugin is just going to take in a repo, and it's going to output some repo statistics. So now if we go to each of my plugins, we'll just start with, let's start with GitHub. That's the one most people are familiar with. So you can sort of see that here I have a GitHub plugin. The base is the parent class is the base plugin. And here I have a function called check. It's going to check to make sure that the domain of the URL passed in is GitHub. That's how it knows it's a GitHub that's how it knows that it should be using this plugin. And then going out, it goes to this endpoint, pulls out our repo stats, and generates sort of an object. And if we go to our GitLab plugin, it's sort of the same thing. It's like I'm inheriting from that same parent object. I have that same check function. Here I'm just checking against a different domain. And at the end, when I'm generating stats, I'm using the GitLab API and pulling information in that context. Sort of the same way with Bitbucket. Like it's the same code, except it's really driven for Bitbucket. And now if we go back to our driver class, here I'm like registering my plugins explicitly. And we sort of talked about this before. So you can sort of see that if you ever wanted to add maybe like a different type of like provider, maybe like what is it, SVN releases like SVN Hub, and you want to track those stats, you can just like post those things and get that as you need. Cool. So this is really just a really high level overview. I wanted to give a little bit of a talk just because we have two guests from outside of Chicago. Wanted to keep that Chicago culture going. I'm going to be giving a longer version of this talk at the Python Web Conference. I believe my date is going to be on June 19th. So if you're interested in learning more about plugins, you can get tickets at that website. But we are giving away one ticket tonight and one ticket during the main meeting. So go to this URL, fill out the form, and at the end of tonight, we're going to pick out a lucky winner. That's it for me. I won't be sharing slides. This talk is sort of a work in progress. You could really tell like I'm like rambling here. Don't really have much of a flow. But if you do have advice on how I can present these concepts in a way that's easier to understand, please reach out. We'll love to chat about this. But yeah, just very early stages of my talk. So thanks everybody for listening. I'm just gonna clap for myself. All right, so we do actually have some questions. So we have a question coming in. Are there any security risks with running plugins from users? Yeah, that's definitely a problem. So when you do download a plugin, so say maybe for like Chrome, like that app store, it makes sure that they'll probably do some checks to make sure that this app does not have malicious code. But if you're just downloading something from like GitHub and just putting it in a folder without reading the code, you do open yourself up and open up your computer to be hacked a little bit. So one of the plugins I was working on that keeps things in a folder, it's a macro keyboard called the Elgato Stream Deck, and that's the one that uses WebSockets I was talking about. And they're like, I haven't like they do have an app store, but not everybody puts their applications on that store. So you have to sort of search GitHub to find these applications. So I found something. They hacked together a Python solution using like WebSockets. I read through the code before I implemented it. So yeah, just a little be careful with like what you're doing. I'm just gonna leave it that for me. If you do have questions, I'm gonna be available. Ask them down below in the YouTube chat or find me on Slack. I'm always there. So thanks everybody for listening. Cool. So next up, I'm going to be bringing in Derek Steinmoeller to Chicago Python livestream. Welcome, Derek.
Hi, Sivji. How are you doing?
I'm doing good. For those that don't know, Derek and I went to college together long time back in the day from the fantastic University of Waterloo. Go Warriors, I think.
Warriors, yeah.
Yeah, go Warriors. Awesome. Yeah, we're more of like a math and engineering school, less of like a sports school. Awesome. So Derek, please introduce yourself to our Chicago Python audience.
Hi, ChiPy. I'm Derek Steinmoeller. I've got a PhD in applied mathematics, specializing in fluid dynamics and numerical methods therein. After finishing my PhD, I transitioned into the software world, working for a large Canadian SaaS company called Desire to Learn Incorporated, or D2L. They ship a learning management software, LMS. So I was there for 4 years, and then I kind of got drawn away by a hydrogeological consulting spinoff from the University of Waterloo called Aquanti. They're a small consulting shop, but they wanted to leverage some of my expertise that I picked up in the field. So it was pretty appealing, and all along numerical methods all the way. I've been looking at ways to leverage my skills both in terms of C++ and how to expose those skills to the Python community and how they can tap into some native code. So that's kind of what this talk is about. So I look forward to giving it.
Awesome. Yeah, like that's sort of the classes we had together were like all those fantastic numerical. Was like CUDA, I don't even remember this stuff, but it was great. But like you've been doing a lot of math. We did a lot of MATLAB in undergrad. So like, how did you go from MATLAB and all those things to Python?
Yeah, so I used MATLAB throughout my PhD, and I kind of was scared of doing native code in C or Fortran or C++. And it wasn't until I went off to a summer school set off by SIAM, which is the Society for Industrial and Applied Mathematics, in 2012. And what they did was they introduced me to the world of C programming and Python programming by sort of the gods of numerical methods at the time. So this is like Randall Levesque, the finite volume god, and Frank Giraldo, kind of a centerpiece in the finite element literature. So what I learned from those guys is like, hey, like, I'm a mathematician, but there's nothing scary about writing native code. So it was quite a learning experience, but it sort of pushed me in that direction of like, hey, I can code and I can get back into the software industry.
Yeah, it's like going from math, I feel like isn't that much of a jump, but there's still definitely like a lot to learn. Like we're all gonna be running into those like segmentation falls of like not knowing what to do, like all the time.
Absolutely, and it's certainly a learning curve, and I had the luxury of being sort of insulated on a DevOps team at D2L there, and getting to learn some .NET and some of these other prevalent technologies that aren't quite up my my numerical alley, but it all interplays nicely. So it's
yeah. So just to build on that, like a lot of folks in the ChiPy community are career changers. And like, how do you feel like your skill set being a mathematician translated well over to being like a software engineer?
I think it has a lot to do with being able to think for yourself and being able to dig for yourself. Like, there would be things that like my supervisors in applied math wouldn't know, and I'd go like dig up a paper and I'd say, like, hey, look at this. What do you think of this results? And they'd be like, well, I hadn't seen that before. Why don't you try doing something with that? And then I would try it and it would work. And then it's like, well, if I can do this, then there's certainly other things I can do. And it's just something you got to realize. Like, not everybody knows everything. But if we know where to look and we know how to Google, in the modern parlance, anyone can do anything if you're driven enough.
Yeah, that's definitely a great point. And CS is very fortunate to have an industry where it's sort of, I feel like opinions are changing. More people are becoming like bootcamp grads, like career changers later on versus the traditional CS route. But to get serious for a second, it's been a little tough for the past few months. Everybody's been sort of stuck at home and like they're sheltering in place. How have you handled the COVID-19?
Have I handled COVID-19? Well,
yeah.
It's been tough. Like we've had to pull in support from my parents and sending my 5.5-year-old off to them so I could do my work during the day, and basically like it's been a sort of a coming together of it takes a village sort of thing. Basically, I'm finding myself giving leeway. Like some days, like I feel like my household really needs some attention here. I'm going to do a lot of cleaning up. I'm going to do a lot of like picking up around the house. Let the software stuff slide a little bit. And then other days it's like, oh, we're hitting a deadline. Like maybe some client expects something. It's like, okay, let's let the housework slide a little bit and let's double down on coding for a few days and just really make sure that's knocked out of the park. But I mean, like there's got to be a balance. It can't always be this running back and forth between the two worlds. There's got to be some kind of like middle ground, I think. But it's hard to find, and I commend people who are able to find that work-life balance even in these crazy times.
Yeah, it's I feel like my productivity isn't what it used to be, but it's starting to come around. The side projects are like sort of stopping. Like it's getting harder.
What can you do? Like I'm sort of in a book project with my former supervisor, and it's like, yeah, like that lady from Elsevier really wants something by like June 21st, but like if it doesn't happen, I'm not going to cry about it. So.
Yeah, fair enough. Well, awesome, Derek. Thanks so much for sharing a little bit about yourself. Are you ready to get started with your talk?
Yeah, for sure. I'll take it away from here.
Awesome.
All right. So we're seeing that okay?
Yeah, we are good to go.
Okay. So this is my Boost.Python tutorial. I gave it about a month or two ago at my WattPy meetup. So this is very exciting to be able to give it to ChiPy here. So I'll start with what is Boost.Python, and I break it down from a pros and cons point of view. Basically, what Boost.Python does is it enables you to set up a declarative or chaining style interface to bind functions in a Python extension module to a C or C++ method. And it actually enables you quite easily to write Python wrappers, as opposed to just going to those bare bones kind of roots of CPython and figuring out how to bind code. There's performance and style gains of native code with the user friendliness of a Python API when you're done binding your code. So what you get is basically Python objects and functions that call into C++ code, and everyone just thinks they're just calling a pure Python library, and in fact they are calling native code. So what are some of the negatives here? Well, you need to carry around these binary dependencies with your Python project now, or your Python bound to C++ project. So you need a DLL or a shared object library. So if you're using Python 3.7, you need Boost.Python 3.7.so. And if you're doing something numerical and you're using NumPy, then you need Boost NumPy. So with Python, how it resolves dependencies at runtime means it's difficult to use all C++ features, and especially templates, which rely on static dependency resolution. There's actually a similar lightweight header-only library out there. It's called PyBind 11. The 11 stands for the C++ 11 standard. And I actually learned about PyBind 11 after having written all the bindings in Boost.Python. So I'm going to continue carrying the torch for Boost.Python, even though I'd caution anyone or suggest to anyone starting out a bindings project to check out PyBind 11, because it might relieve some headaches later on. And as a final note, and I'll get to this later in the talk, packaging projects that have native dependencies can be challenging. And there's a couple of reasons for that. So how do you get Boost.Python? If you're in an Anaconda or Miniconda environment, it's pretty simple. Although this package seems out of date, the last time I checked, you can do conda install py-boost. Or if you want the bleeding edge stuff, you build from source. And the way that's done, you can, on a Unix-like system, you can just download the tarball, untar it, and then basically there's a 2-pass kind of system for setting up Boost.Python and installing it in your system. And you call the bootstrapper and you say, you have to tell it explicitly, I want the libraries for Python and NumPy, and you have to point it at your Python binary. And there's one last trick. You have to somehow either by changing the text files, and I never really got this right, or by setting an environment variable, which I did figure out how to do. You have to point it at where your include path for the pyconfig.h is. And then you call into Boost's home-built build system, which is called B2. It's short for Boost Build. And you tell it where you want to install it. That's the prefix, Boost 172 in this case. You say, I want with Python, I want the release variant, not the debug one. I want to do shared linking and not so dynamic and not static linking. You can tell it to build with multi-threading, and you want the runtime to run on shared. And you can choose which tool chain you want. So in this case, I'm specifying GCC, and I'm saying we're going to install as well. And stage is the other alternative. What about Windows? So it's the B2 system is meant to be cross-platform. I haven't actually delved in and tried this, but they have a bootstrap.bat, which is essentially the replacement of bootstrap.sh. And you would run that with the same arguments. And then you'd run b2.exe with, or whatever kind of executable file it is. The supported tool chain seems to be Microsoft Visual C++. So I've seen some GitHub threads about complaining that MinGW doesn't work, so I wouldn't recommend that. But maybe some of these other platforms like SIG or Windows subsystem for Linux might work. But I'm not a huge fan of Windows. Like, I'll ship to them, but it's been a love-hate relationship for me in my career with Windows. So say you install your Boost.Python libraries, you want to write your first binding. So canonically, you want to find that hello world example, and you want that to be your first implementation. So what does that look like on the C++ side? You'd pull in the Boost.Python library, and you can create a struct or a class called greeter with a standard constructor, and then you have a method that says hello world with a new line. And then that's all standard boilerplate C++. But then where it gets interesting is you say, I'm going to have a Boost_Python_module called hello. And it's going to bind the class greeter. So you're passing the type into the template argument to the Python object greeter. and then you're going to say it's got the init default constructor, and you're also going to define the greet_world Python method to bind to the greeter : greet world method in C++. So, forget about all the fancy build abstraction we have these days. Say you want to just straight up call the G++ compiler. I don't know why you'd ever want to do this, but because we have a single C++ file for our hello world -py file, let's just do it. So you pass in the optimization parameter to G++ -o2. You tell it where the Boost include files are, so -i Boost installation root. You pass in where your pyconfig file is, so user include, or I guess USR stands for Universal System Resources, not user. So silly me. USR/include/Python 3.7m. You pass in which C++ file you want to build, -f PIC for position independent code. And then we tell it, hey, link to Boost.Python 3.7. And then it turns out you have to pass in some linker flags. So you have to set the so name. Sorry, my cat's going nuts here. That's just COVID-19 result. But so name, hello, and you want to make it a shared library, and the output is hello.so. So if you test that out, I did this to make sure that this example actually works. You can try it at home. You can impress your wife and kids a lot, or your husband, as the case may be, life partner, whatever. Python 3.7 import hello, greeter, hello.greeter, greeter, greet world, and then you get the result hello world. So a lot of work for hello world, but that's kind of the point of hello world, I guess. So say you wanted to expose a Python list, and you wanted to do it with a few C++ static methods. If you want to make it cross-platform, you need to explicitly tell MSVC what you want to export in your DLL and what names you want to expose, whereas like the GNU compiler toolchain will assume you want to export everything because Go open source. So basically, you have that distinction there with your class declaration, and then you say, all right, I'm going to have a public method. It returns a Boost Python list, or just a Python list, but Boost is the one who's providing the internals there. And it's you say, okay, so my coefficients for Runga 4 are going to be a Boost Python list A, and I append all those coefficients, and then I do the same thing for the Runga B coefficients. So this is what Sivji was joking about, is like our numerical methods for Adams, Bashforth, and Runga, these mathematicians who came up with the underpinnings of numerics. So getting to exposing lists with static methods, continuing on with that, to write the binding, you say, all right, I'm going to take my C++ class, I'm going to bind it to a Python class called lcirc4, and I'm going to define a bunch of read-only properties. So you can say, because it's a static in C++, you have to say it's an add static property, but you give the Python name followed by the address of the C++ method, and then you can provide a doc string optionally. And then if you jump into Python 3.7, you can import that module, look at the various properties, and see, yes, they are what they should be. And the great thing about filling in doc strings there is you get automated auto pydocs, as the slide suggests. So you can type help on an object, and you get this nice reference sheet explaining how your Python methods are bound to C++. So it's quite powerful. It does a lot for you. It's really great. So if you don't like just calling G++ directly, of course, there's make, CMake, MSVC, other things. But if you're interested in shipping your module, you'll want to consider using setup tools if you want to build a wheel or something like this. So just to show you what that looks like, you will want to import the extension class from distutils core, and then you'll be able to use the the extension class to define what your extension is and what source files it has, what dependencies it has, and so on. So here you pretty much have a standard setup clause where you define your version metadata, the contact author, the description, and so on. And then you say like what platform tags does this project support? So in this case, Many Linux 2010, Windows 64, Mac OS X. And then the extension class can be called to say like, all right, there's extension modules in this project. Here's what they are. Here's what their dependencies are. Here's how to compile it. So a bit heavy in terms of, how long it is, but it's all pretty much the same arguments that you'd pass to just G++ if you had to compile it directly. So then once you've got your setup.py file written and validated, you can just build your wheel as a binary distribution, and you can also build a source tarball with sdist. So what I'd recommend for anyone who's building native extension modules to check out Audit Wheel, because it takes any like sub-dependencies of your project and bundles them in with your project. So it's kind of an interesting exercise. What it does is it takes SHA-256 hashes of any sub-dependency of your project, and then renames those shared object files to contain that hash. So what you have to do then is mangle any code binary code that references those modules, and then change the names accordingly. So there's a lot of binary mangling and crazy stuff going on, but that's for another day, I guess. So the other note, there are specific containers for building Python native extension modules for C++ that need to be used if you're going to publish to PyPI. So those are in the form of PEPs, and there's one called Many Linux 2010, which is the more recent one, and then Many Linux 1, which is the original one. And there's talk of Many Linux 2014, which is based on Ubuntu 2014. And the idea there is, well, I'm going to take a really old version of Linux that future versions of Linux are going to be dependent on, and then naturally, since things are backwards compatible, if I build on that really old version, then I'll support a whole bunch of versions of Linux moving forward. So it's kind of an interesting idea and an interesting exercise, but just take note that you never want to label your project as Many Linux or fake the metadata files, because you feel the wrath of some of these Python wizards that are out there. So here's an example of Antoine Potru commenting on the TensorFlow project, saying, just chiming in here, it's counterproductive to claim your wheels are Many Linux 1 compliant when they in fact aren't. This is producing annoyances for other projects in the ecosystem, the Python ecosystem, who have to deal with bug reports such as PyArrow crashes when I try to use it alongside TensorFlow +7. And then this prompted the TensorFlow guys to pitch the specification for Many Linux 2014. So we'll see how that goes. So I was supposed to remind you to ask your questions about 5 minutes ago, but feel free to ask me any questions. Hit me up on Twitter, or I guess GitHub doesn't have messaging, but I am at DSimo on Twitter and GitHub. So thanks very much for listening. I hope you learned something.
Thanks so much, Derek. Can we give Derek a round of applause in the chat? Also, we do have some questions coming in. While we're waiting for that, it's like, what are some of the performance, like how much performance can you gain from going from Python to just like Python bindings for C?
That's a good question. It's not one that has a direct answer because it's very context dependent. I would say that quantifying the performance of Python itself is in particular a challenging proposition, because Python has just-in-time compilation, and things like Numba and such are making things more native-ish, like every day. Certainly, if you find Python is slow, like you have a doubly nested loop and you're going over an array, like maybe if that's the only way of doing that, and you can't vectorize it within Python, consider writing a C++ binding into it and seeing what the performance gains are. It's very hard to like look at a piece of code and a priori say like, hey, this is slow, let's C++ify it. Like, it doesn't really work that way. You got to sort of dig and experiment yourself.
Yeah, you should always, before you do anything, always measure code. I would love somebody out there to give a talk on like C profile. That'd be fantastic if anybody's out there listening.
Yeah, that would be great. Sign me up for that one.
Yeah. We do have a question coming in. So how have you used C++ libraries within Python for either work or personal projects?
Yeah, that's a good question. So as I mentioned, I'm sort of a numerics junkie by trade. So when I finished my PhD, I said, I did enough MATLAB. Let's try to learn some C++. Let's try to make some performant things. And so my main project with the WQCG, or the Waterloo Quantitative Consulting Group, which is a not for profit I started, is a suite of numerical solvers that have Python bindings for them. So it actually started out as a C++ project. And I just said, hey, it's going to be GNU licensed. It's going to link to everything that's already out there. I'm not going to reinvent the wheel. So then things like Audit Wheel became extremely powerful for me. And I could just pin dependencies based on their SHAs and link here, there, and everywhere to things I want. Pull all those other C++ or C or Fortran or whatever it is libraries in, and just leverage them, because why reinvent the wheel and just use it the way it's already optimized.
That is like the most Python like way of thinking. It's like we got so many other things out there. Like, let's not reinvent anything.
Yeah, exactly.
So we have a part 2 of that question, but they're not really related. Like, how would you recommend getting better at mathematical thinking in order to improve problem solving in an algorithmic sense?
It's an interesting question. I kind of found myself, even with a math PhD, struggling algorithmically when I came out of school. I didn't find it to be a clear-cut path. Basically, you have to sort of read about the different ways that one solves an algorithm's problem and then figure out which one suits your personality style. For me, it's example or exemplify is what you read about. So what you do is you're given a problem and you're like, oh crap, I can't solve this at all. So you just start writing down examples, like maybe for the case where there's like 3 elements in my list, I can solve this problem by doing this. And then you say, well, there's 5, maybe I can do it this way. And then suddenly a pattern emerges. But there's other ways and there's other schools of thought. So I wouldn't get like hogtied in any one particular way of thinking, and just find what works for you, find what's out there and try your best.
Yeah, like I think the one thing that like really helped out like doing math was you learn so many different ways of attacking a problem. I was just looking on my bookshelf. There's a book I have called How to Solve It by Polya.
Okay, I've heard of that one.
Yeah. That's a very famous book. I mean, it's on my shelf, like so many other books on my shelf that I have not read. But if you're looking for a way, he's a very famous, I believe, Hungarian mathematician.
I don't know.
Yeah. So check that out.
Yeah.
So before we do let you go, thanks so much for this fantastic talk. Can we get Derek another round of applause in the chat? Do you have any takeaways or action items or words of wisdom for our community?
I do, and it's be a life learner. Never stop learning. That's my call to action. Just do it. Whatever you want to do. You think that learning comes to an end at some point in your pedagogy or your career, and the answer is no. Always look for new things to learn.
Yeah, that's fantastic advice, like especially in this field where things are going to be coming out probably forever. Like we're just going to add another levels of abstraction on top of things we already have.
Absolutely.
Awesome. Well, thanks so much, Jerry, for joining us, and look forward to hanging out again.
Yeah, let's do it again.
All right, man. Take care. Have a good night.
See ya.
All right, so that was Derek Steinmoeller talking about Boost Python C++ bindings. Oh, right now we're going to be closing out the meeting and doing our giveaway. Let me actually just get my screen shared. I feel like I am not as on it as I normally am. Okay, cool. So I have a list of folks in a Google Doc. I'm not going to bring all that doc onto the screen. I'm just going to copy and paste names. So we have a total of 8 names. So let me just do some live coding. Oh, this is going to be, I'm already feeling the pressure. So variable names are very important, right? People equals, so coming as a string. Okay, so folks equals people, person dot strip for person in people dot splits. I really wish I wrote this ahead of time. So here I am just splitting on the new line. Perfect. And from random import choice dot, well, forgot my variable names. That's why you don't clear your screen. So choice folks. All right, so Pablo, congratulations for being our winner. I will be reaching out to you with details on how to redeem your free ticket. So that's going to be it for us. Thanks so much, everybody, for joining. Let me actually share my see our upcoming events just so we can close out the meeting. You know what? I can't find it. All right, so if you go on Meetup, it's going to be, our next event's going to be on Thursday, June 4th. Main meeting is going to be June 11th. That's another Thursday. It's going to be next Thursday. And then finally, we have, to round out the month, Data Special Interest Group, which is going to be a night of natural language processing. That's going to be on Wednesday, June 17th. Who needs a reminder when you can just remember off the top of your head? Awesome. So for that last meeting, for that DataSig meeting, just want to make everybody aware of our fantastic lineup. We have Lorena Mesa. If you're involved in the Python community in any way, you probably know who she is. She started Chicago PyLadies. She sits on the board of the Python Software Foundation. She's going to be giving a talk on how to generate a telenovela script using deep learning. And we also have Ryan Bales encoring his talk from PyTennessee and PyOhio, learning from audio data. So 2 fantastic talks. Looking forward to that night. Well, that's it for us for tonight. Thanks so much for tuning in. And if you've stuck around this long, go ahead and give this video a like. And also go down, if you have not done so, subscribe to our channel, hit that bell icon. We have upcoming events, and we're going to keep going to do virtual events for the foreseeable future. So thanks, everybody, for tuning in. We'll catch you later. My closing music. Doo, doo, doo.